Welcome to Lecture Online. Here in this example, we're going to make a substitution in order to make the variable separable, as we call it, but not the substitution of y over x. When we look at this equation, notice we'll see an x minus 2y, and then we see a 2x minus 4y. So it's kind of repeated. Think of this as 2 times x minus 2y. So let's try this substitution. Let u equal x minus 2y and see what we get. Okay, when we do that, oh, and by the way, how do we substitute for y prime? Let's do that as well. So let's solve this for y. Move the 2y on the other side. We get 2y is equal to x minus u. Notice I put the minus 2y on the left side becomes plus 2y. The u on the other side becomes a minus u. So we get y is equal to 1/2 times x minus u. And so therefore dy dx is equal to 1/2 times the derivative with respect to x is 1 minus the derivative that would be u prime. So this can be written as 1/2 times 1 minus du dx. All right. So now we have substitution for y prime, because this is y prime. Okay, I was looking for my y prime, I couldn't find it. I wrote it as dy dx. So now let's go ahead and make the substitutions and see what we get. So this becomes 2 times u plus 5 multiplied times y prime, and y prime can be written as 1/2 times 1 minus u prime. I'll write it as u prime for now because we have to simplify it algebraically. That would be plus u plus 3 is equal to 0. All right, now we should have something that we can separate and integrate. But we may need to do some algebraic manipulation. Let's see what we get here. So first of all, let's get rid of all those parentheses. So when we multiply this in here, we get u plus 5 over... I might make it easier yet. Let's go ahead and get rid of the 1/2 by multiplying both sides by 2. Let's do that instead. All right, so when we do that, we get 2u plus 5 multiplied times 1 minus u prime plus 2u plus 6 is equal to 0. All right, that's probably a better way to do it. Now we go ahead and multiply this through, so we get rid of the parentheses. So this gives us 2u minus 2u times u prime plus 5 minus 5 times u prime plus 2u plus 6 is equal to 0. All right, let's see here. Well, I have a 2u here and a 2u here. I can combine that and have a 5 and a 6. I can combine those. So let's do that. We have a minus 2u u prime minus 5u prime. That's these two terms right here. Plus 2u and 2u gives me 4u, and 5 and 6 gives me 11. All right. Now what I'm going to do is I'm going to move the 4u plus 11 to the other side. That becomes minus, but then with these minus signs, I can turn everything back into positive. So I can write this as 2u u prime plus 5u prime is equal to 4u plus 11. So I move this to the right side. That becomes negative, but then I multiply both sides by -1 to get everything to be positive. Now I factor out a u prime. So I can write u prime times 2u plus 5 is equal to 4u plus 11. So finally, u prime is equal to 4u plus 11 divided by 2u plus 5. And so if I write u prime now as du dx, so I have du, I said du and I wrote dx, so du divided by dx is equal to 4u plus 11 divided by 2u plus 5. And finally, I can use the separation of variable technique. So I can write 2u plus 5 divided by 4u plus 11 times du is equal to dx. Now I'm ready to integrate both sides. However, when I look at this and say, wow, how do I integrate that? Maybe what I should do here, since this is u to the first power and u to the first power, I'll simply use the longhand division, divide the denominator into numerator to come up with something that's probably easier to integrate. Let's try that over here. So let's divide 2u plus 5 by 4u plus 11. So I can say that 4u goes into 2u 1/2 times. So 1/2 times this gives me 2u 1/2 times this gives me plus 5.5. If I subtract this from that, I get 0 minus 1/2. Right, what this tells me is that this divided by that can be written as, so this is equal to, or maybe I'll just write it like that, which means that 2u plus 5 divided by 4u plus 11 can be written as 1/2 minus 1/2 divided by the divisor, which is 4u plus 11. All right, let's see here. That's good enough. Go ahead, let's do that. So this is equal to 1/2 minus 1/2 divided by 4u plus 11 du is equal to dx. And so the best thing to do here, again, is multiply both sides of the equation by 2 to get rid of those 1/2s. When I do that, I get the following. I get 1 minus du over 4u plus 11 equals 2 dx. Oh, wait a minute. I can't write it like that. I need to write my du over here because the du applies to both the 1 and the 1 over 4u plus 11. Okay, that's a little sloppy here. Equals. All right. Now I'm thinking I'm ready to go ahead and integrate both sides. So let's integrate the left side. Let's integrate the right side. When we do that, the left side, this is 1 times the u. That's simply u plus, no, not plus, I have a minus here, minus the integral of 1 over 4u plus 11 du. The reason why I wrote it like this is because I'm not ready to integrate yet. I don't have the proper differential. On the right side, that's easy. This is equal to 2x plus some constant of integration. But notice, in order to integrate this will become the natural log of 4u plus 11, except I don't have a proper du. A proper differential would be a 4 du, which means, and let me use a different color, that means I need to multiply this times 4 and divide by 4, like that. So now I have a proper differential in the numerator. I can go ahead and integrate that. So this now becomes u minus 1/4 times the natural log of the denominator, which is 4u plus 11, equals 2x plus some constant of integration. Ooh, why did I write 1/2 when I have a quarter there? Got to be careful. It's 1/4 times the natural log of 4u plus 11. Okay, I don't like that 1/4 there, so what I'm going to do now is I multiply everything by 4, see what we get. So we get 4u minus the natural log of 4u plus 11 is equal to 8x plus some other constant of integration. Oh, let's call that c sub 2 because c sub 1 times 4 is c sub 2. All right, now I think I'm ready to substitute back in what I have. So let's do that. Let's go ahead and substitute back in. So 4 times u becomes 4 times x minus 2y minus the natural log of 4u becomes 4 times x, which is 4x, minus 4 times 2y, which is 8y, plus 11, is equal to 8 times x plus c2. All right, getting rid of the parentheses here, this becomes 4x minus 8y minus the natural log of 4x minus 8y plus 11 is equal to 8x plus c2. I can go ahead and bring the 4x to the other side, becomes 4x. So let's do that. We have, and multiply both sides by a -1. That gives me 8y plus the natural log of 4x minus 8y plus 11 is equal to, remember this was an 8x minus 4x, but I multiply times the -1, this becomes a minus 4x plus c3, which is c2 times the -1. And that's the right answer, but maybe I don't like that format too much. Maybe I'll write it like this instead. So let me go ahead and say, how about 8y plus 4x plus the natural log of 4x minus 8y plus 11 is equal to some constant of integration, and we'll probably want to leave it like that. So there we go. That's probably the best way to write the final solution. But again, the technique is what's important. We came up with an initial differential equation. Didn't look like we could do anything with it until we saw that x minus 2y is repeated on the left side and the right side. This is 2 times x minus 2y, 1 time x minus 2y. Make the substitution, solve for y prime, substitute that back in, and then you end up with something you can indeed integrate. And that's how we use this technique. Even if it's not y over x, we can still use the same principle to come up with something where we can separate the variables and solve for the differential equation. And that's how it's done.